and welcome. Today, we are going to crack a code, a secret language that, believe it or not, describes how the whole world works. And to get started, how about we play a little game? All right, I want you to play along with me right now. Just follow a few simple steps. And hey, don't worry, I promise the math is super easy. Okay, you ready? First step, think of any number you want. Got it? Now, multiply that number by 2. Next, add 20 to your new total. Okay, take that result and divide the whole thing by 2. And for the final step, subtract the very first number you thought of. You got your final answer? Okay, let me take a wild guess. Is your answer 10? Pretty cool, right? I'm telling you, this works every single time, no matter what number you start with. Go ahead, pause, and try another one if you don't believe me. I'll wait. So how in the world does that work? Is it some kind of mind-reading trick? Nah, not at all. The secret behind this little bit of magic is actually the star of our show today, algebra. Yeah, algebra. But it's not just about those complicated equations you might see on a chalkboard. When you get right down to it, algebra is really the language of patterns. It gives us this incredibly powerful way to describe the rules and relationships we see all around us. So what is it, really? Well, to put it simply, algebra is just a part of math that uses symbols, you've seen them, letters like X or N, to stand in for numbers that we don't know yet. It's basically a tool for talking about the unknown. You know, there's this fantastic quote from mathematician William Paul Thurston that just hits the nail on the head. Math isn't just about crunching numbers. It's about understanding the how and the why behind everything. And algebra, that's one of our best tools for getting that understanding. Now, to speak this new language of patterns, you gotta know its alphabet. And the most basic building blocks of algebra are these two little concepts, variables and constants. First up, we've got the variable. The easiest way to think of it is like an empty box or a placeholder. We just use a letter, say N or X, to hold the spot for a number that can change, or maybe a number we're trying to figure out. And on the other hand, you have the constant. And just like the name suggests, its value is, well, constant. It's fixed, it never changes. So if you see something like n plus 3, our variable is n, but our constant is 3. It's always going to be 3. So let's break it down real simple. Variables can change. Constants stay the same. That's pretty much it. Let's look at a real-world example. Say Mathi is 3 years older than his sister, Nyla. Okay, if we call Nyla's age n, our variable, then we can always describe Mathi's age as n plus 3. And you can see here, as Nyla's age n changes, the expression still works perfectly. If she's 4, he's 7. If she's 8, he's 11. See how that works? Okay, so now that we know the basic building blocks, let's put them to work. This is really the heart of algebra, using what we already know to figure out what we don't. We are going to solve for the unknown. Here's a little puzzle for you. Imagine you have a tray of eggs. You take 6 of them out to make breakfast, and you look down and see you've got 10 left. So, how many did you start with? Now, you can probably figure this out in your head, but let's see how algebra gives us a really solid way to solve it. So, we can translate this little word problem into a clean algebraic statement. Let's use the variable x for the starting number of eggs we don't know. So x, our starting number, minus the 6 we took away, equals the 10 that are left. X minus 6 equals 10. Now all we have to do is find the value of x that makes this statement true. We can just test some numbers. What if we try x equals 12? Well, 12 minus 6 is 6, so nope. How about 15? 15 minus 6 is 9, still not 10. But what if we try x equals 16? Bingo! 16 minus 6 equals 10. So x has to be 16. We started with 16 eggs. Okay, let's try another one. Mughlan is 6 years older than his brother, Athian. So if we let Athian's age be the variable p, then we can always find Mughlan's age with the expression p plus 6. But what if we're given another piece of the puzzle? Let's say we actually know that Athian, our p, is 20 years old. Well, we just plug that value right into our expression. Instead of p plus 6, it becomes 20 plus 6, which equals 26. Simple as that. We just found Mughlan's age. And this brings us to a final, really powerful idea. Algebra is basically a shorthand for language. It lets us take these long, sometimes confusing statements and boil them down into simple, clear expressions. Just look at how easily these sentences translate into math. X is increased by 21 just becomes x plus 21. 7 is taken away from A is simply A minus 7. Twice P, that's just 2P. It's a clean, universal language. So what's the big idea here? It's that algebra is so much more than just a bunch of letters and numbers. It's a tool for thinking. It gives us a way to describe the patterns that are happening all around us, and a system for solving problems when we have missing pieces of information, from simple puzzles like our egg problem all the way to the complex models that run our world. So now that you're in on the secret, I'll leave you with this question. Where can you find hidden patterns in your own life? I mean, think about it. Calculating how long a trip will take, splitting a bill with friends, even just adjusting a recipe. The world is absolutely full of these little problems, just waiting to be described by this powerful language. Thanks for tuning in.